Assalamu alaikum wa rahmatullahi wa barakatuhu. Students, today inshallah we will see frequency distribution or frequency diagrams. Okay, so data in form of grouped frequency distribution are generally represented by frequency diagrams such as histogram, frequency polygon, frequency curve, and ogive. Okay, so what is, I have told you, data in form of grouped frequency diagram. So what are the data which is in form of grouped frequency diagram, which we have already studied, see, like, such as 0 to 5, 5 to 10, 10 to 15, 50 to 20. So all these are the data which are in form of grouped frequency diagram. So such data are generally represented by frequency diagram such as histogram, frequency polygon, frequency curve, and ogive. Okay, so now we will see what is histogram. Histogram is a two-dimensional diagram. Okay, it is a set of rectangles with base as the intervals between class boundaries and with area proportion to the class frequency. So if the class intervals are of equal width, okay, which they generally are, the area of rectangles are proportional to their respective frequency. Okay, but sometimes it is always convenient to use varying width of the class. See, for example, if you are taking the tabulating death by age at death, okay, if you're taking the tabulating deaths, okay, by the age of death, it would be very meaningful as well as it would be very useful to have very short age interval such as 0, 1, 2 years or 0, 7 days, 28 days, or such things. Okay, so at the beginning, when death rates are very high compared to the deaths at most other higher age segment of the population. So for graphical representation of such data, height of area of rectangle is the quotient of the height and the base. So when intervals are equal, that is when all rectangles have the same base. Okay, see, when the size of the class interval is equal, the base of all the rectangle will be same. Okay, so all the rectangle will have the same base. Okay, and area are conveniently be represented by the frequency of any interval for the purpose of comparison. See, in your textbook they have given you a table which shows the distribution of daily wages earned by locality of a town. See the daily earnings here: 40 to 49, 50 to 54, 55 to 59, 60 to 64. Okay, but here the class interval or the class interval is not continuous. Okay, but if it is not continuous, the first thing what we have to do is we have to convert it to continuous class. So how to convert it into the continuous class? You have to see the difference. 49 to 50, what is the difference? 1. See, the upper limit of one class is 49 and the lower limit of the next class is 50. So what's the difference? It is 1. So 1 divided by 2 is 0.5. So 0.5 should be added to the upper class limit and should be deducted from the upper class limit, and 0.5 should be added to the 0.5 should be deducted from the lower class limit, and 0.5 has to be added to the upper class limit. So when you do so, which this we have already discussed in chapter 3. Okay, so when you do so, you can convert the data which is not continuous into continuous data. So first we have to convert the data into continuous data. Okay, so now we will see how this histogram is drawn. So here we have to take the classes, okay, a class interval on the x-axis and wages on the y-axis. So this is how the histogram looks. Okay, so when you convert this data to the continuous data, your data what you obtain will be 44.5 to 49.5, 49.5 to 54.5, 54.5 to 59.5, like this. Okay, so I have told you class interval has to be taken on the x-axis and frequency will be taken on the y-axis. See, when you see this, it looks same like your bar diagram. Okay, but it is not same like your bar diagram. When you see, there is more differences than similarity between this histogram and bar diagram. Okay, see, in bar diagram you can see small space between each bars, whereas in histogram you cannot see. It's a continuous, it is touching all the bars. Okay, So here, as I've told you, how you have to draw is take 44.5 to 49.5, that is the width, because all the width, the size of the rectangle will be same here, because it is this because the class size are equal. Okay, and frequency is 2. So 44.5 to 49.5, when you draw, see the frequency, you have to, on the x-axis, on the y-axis, the frequency is 2, so you have to reach till there. Okay, and next is 44.5 to 54.5, where the frequency is 3. So 2 plus 1 is 3, correct? So you have to do it till 3. Next is 5. So 54.5 to 59.5, it is 5. So you have to reach the point 5 on the y-axis. So this is how the histogram is drawn. Next we will see frequency polygon. So frequency polygon is a plane bounded by straight lines, usually 4 or more lines. Okay, so frequency polygon is an alternative to histogram, and it's also derived from histogram itself. Okay, so a frequency polygon can be fitted to a histogram for studying the shape of curve. The simplest method of drawing frequency polygon is to join the midpoint of the top side of the consecutive rectangle or the histogram. Okay, it is to join the top side of the consecutive rectangle. Okay, it is to join the, one second students. Okay, it is to join the the simplest method of drawing a frequency polygon is to join the midpoint of the top side of the frequency distribution of the histogram. Okay, it leaves us with two ends away from the baseline, denying the calculation of area under the curve. The solution is to join the two endpoints, thus obtain to the baseline at the mid value of the class of the two class with zero frequency immediately at the each end of the distribution. So the broken ends or broken lines or dots may join the two ends with the baseline. Okay, so now the total area under the curve, like the area in the histogram, represents the total frequency or sample size. Okay, so next we will see the frequency curve. Now frequency curve is obtained by drawing a smooth freehand curve passing through the point of the frequency polygon as closely as possible. Okay, so it is not necessarily pass through all the points, or it may not necessarily pass through all the points of the frequency polygon, but it passes through them as closely as possible. Okay, next is ogive. Okay, ogive is also called as cumulative frequency curve. Okay, and as there are two types of cumulative frequency, for example, less than type and more than type, accordingly there are two ogives for any grouped frequency distribution data. Okay, so here in place of simple frequency, as in case of frequency polygon, cumulative frequency are plotted along y-axis against the class limit of the frequency distribution. Okay, so for less than ogive, the cumulative frequency are plotted against the respective upper limits of the class interval, whereas for more than ogives, the cumulative frequency are plotted against the respective lower limit of the class interval. Okay, so okay, this is all about ogive. Okay, next we will see what is arithmetic line graph. An arithmetic line graph is also called as time series graph. Okay, so in this graph, time such as hour, day, then week, month, all this is plotted on the x-axis, and the value of variables is plotted on the y-axis. And a line by joining these two plotted points thus obtained is called as arithmetic line. Okay, it is called as arithmetic line. So this is called as arithmetic line. So in the textbook they have given you the data, page number 55. Can you all see? Okay, so here you can see year, export, import. Okay, so here this time is taken on the x-axis and the data is taken on the y-axis. Okay, see here you can see that from the period 1993 to 1994 to 2013 to 2014, the imports were more than the export all through the period. So you may notice that the value of both export and import rising rapidly from 2001 to 2002. Okay, also the gap between two, that is the import and export, has widened from 2001 to 2002. Okay students, this is all about arithmetic line. Okay, here we come to the end of this chapter. By now you must be able to know what is data and how it is represented. Okay, how it is represented textually and tabular and also in diagrammatical form. Okay, so here we come to the end of this chapter. Students, if you have doubt you can ask me. Okay, Jazakallah khairan.